multiply matrices. And so yesterday we were working on adding and subtracting them and just displaying data in the matrices. When we said that when we were working with them that we had to have the exact same size matrix to be able to add and subtract. Well, when we multiply matrices, things change a little bit. Right? So when we multiply matrices, if I have a matrix that is m by n, the matrix I multiply it by has to be an n by p. In other words, the number of columns for the first matrix have to be the same as the number of rows for the second matrix. Right? And then the matrix that you're going to get is going to be the number of rows from the first one and the number of columns from the second one. Right? So if we multiply 3 by 2, and we multiply that by 2 by 4, right? Then we're going to end up with a 3 by 4 matrix. Right? So these two have to be the same for me to be able to multiply the number of columns for the first one and rows for the second one. And then my result is going to be the other two. These rows, these columns. Right? So here they show, here we have a 2 by 3 and a 3 by 4. So if I multiply them together, right, which I just did. Okay. Or if we have a 3 by 2 and a 3 by 5, those we can't multiply because these numbers have to be the same. So when you write out the dimensions of them, the middle ones have to be the same for me to be able to multiply them. Okay. So example 1, they just want us to tell whether these can be multiplied or not, and if so, what are the dimensions of the new one. So we have 3 by 4 and a 4 by 2. So I'm looking for the middle two numbers if they're the same. So these are the same. So I can multiply these two together, and my new matrix is going to be a 3 by 2. All right? So the new one is going to have these dimensions as long as these two are the same. So 1 by 4 and a 3 by 4. All right. Since these two are not the same, this is not possible. They cannot be multiplied. Okay, so let's multiply matrices. So, first of all, we know that how the dimensions got to work to multiply them. Now, when we do multiply then, what we do is we multiply the first row of the first matrix by the first column of the second matrix, right? So we multiply rows by columns, and that gives us that entry. So, for instance, when I multiply row 1 times column 1, I'm going to get entry 1, 1 for my new matrix. All right, and we'll show how that works. So here we're going to multiply the first row by the first column. So we multiply 1 and 2 times 5 and 7. So we'll do 1 times 5 and 2 times 7, and then we add them, and that gives me the first entry. When I multiply row 1 times column 2, we'll have 1 times 6 and 2 times 8, which is here. right? And then we add them together. Right? So we multiply, then we add, and that gives us the entry that row times column would be. Right? So row 1 times column 1 is entry 1, 1. Row 1 times column 2 is entry 1, 2, and so on. All right, so I'll write it all out as we're going through here then. So first, WX. The first thing is can I multiply them together? All right, so let's look at them. We have a 3 by 2, a 2 by 3, and this one is a 2 by 2. All right, so write all three of them down in your paper first before we go any. All right, so we're going to do W times X. So first of all, right, we have a 3 by 2 and a 2 by 3. So I can multiply these because the middle numbers are the same. And when I'm done, I should have a 3 by 3 matrix. Right. So, right, here's how we go about doing this then. So I'm going to multiply row 1 by column 1. Right? So we're going to end up with a 3 by 3. So I'll do the left side here. So I'm going to multiply 3 times 4 and negative 2 times 5. All right, and that's my first entry. Okay. Then we're going to multiply 3 times 7 and negative 2 times 1. So this is going to give me row 1, column 2. I'm going to run out of space. Okay. So then we're going to multiply row 1 times column 3. So 3 times negative 2 and negative 2 times negative 1. Go, squeeze it in there, right? And then my right matrix. All right, so there's the first row. All right, I got the first row by multiplying row 1 times each of the 3 columns. Right? So then I got to multiply row 2 times each of the 3 columns. Right? So when we multiply row 2 times each column, we multiply 1 times 4, 0 times 5. Then we multiply 1 times 7, 0 times 1. All right, so that would be row 2, column 2. All right, so entry 2, 2. All right, then we multiply 1 times negative 2 and 0 times negative 1. So we've done row 2 times all 3 columns. Now we do row 3 times all 3 columns. So 2 times 4 plus negative 1 times 5. Two times 7, negative 1 times 1. 2 times negative 2, and negative 1 times negative 1. And the one thing that you should notice then is when you do this is that, let's go, these numbers are the same. Okay, so the second numbers in each row, right? 4, 4, 4, 5, 5, 5, right? 7s, 1s, negative 2s, negative 1s. So those are all the same. So you should see that pattern. Right? And then also horizontally then, 4, 5, oops, excuse me, 3, negative 2, 3, negative 2, 3, negative 2, 1, 0, 1, 0, 1, 0. Okay? So the rows and the columns are going to be like that. So now all we need to do is to finish this is we need to do that multiplication and addition then. All right, so my answer is going to be a 3 by 3. So 12 minus 10 is 2. 21 minus 2 is 19. Negative 6 plus 2 is negative 4. Four plus 0 is 4. 7 plus 0 is 7. And negative 2 plus 0 is negative 2. 8 minus 5 is 3. 14 minus 1 is 13. And what we got? Negative 4 plus 1 is negative 3. All right, so there's my answer. All right, so we multiply the row by the column and we add. All right. Okay, so we'll do another one. All right, x times w. So x times w is a, let's see, what is x times w? All right, we have a 2 by 3. And a 3 by 2. All right. Oh, they did it for us. Okay. All right, so we check the dimensions. The 2 by 3 and the 3 by 2, so the product is defined and it works. All right, so we're going to end up with a 2 by 2 when we multiply them. All right. Let me just put it up here. All right, so we're going to change the order of them. This one's first. This one's second. Okay? So now we're going to have 3 numbers that we multiply together and add. Because we're going to multiply this row by this column. And so we're going to end up with just a 2 by 2 when we're done doing this. So we'll do 4 times 3, 7 times 1, negative 2 times 2, and then add them together. Right, that would be row 1, column 1. Then 4 times negative 2, 7 times 0, negative 2 times negative 1. Right? Multiply them together and add them up. Right? And then that will give us row 2, column 2, or row 1, column 2. Right? Then we multiply row 2 times column 1. 5 times 3, 1 times 1, negative 1 times 2. and then row 2 times column 2. So when we do that, so we do that then, all right? So we're going to get all this right here would be the stuff that we're going to add together. So our final answer then will give us 15, negative 6, 14, negative 9. All right, so notice that multiplication with matrices is not commutative. All right, what does that mean? It means I can't just switch the order, okay? 5 times 8 is 8 times 5, right? But in this case, W times X is not the same as X times W, all right? So just by switching the order, we don't get the same matrix. And sometimes you can't even multiply them in that situation. But this time it worked out. All right. How about X times Y? So we check the dimensions first. Two by 3 is X. 2 by 2 is Y. Those we can't multiply, all right, because the middle number is not the same. It's not possible. All right. All right. So if you can multiply them together, multiply them together. All right. So with our calculator, so we're going to go ahead and put all 3 of these in our calculator for the moment to do this then. So we go to, for matrices, if you look at the X inverse, the inverse key here, right? Matrix is right above that. So if you go second, and this X negative 1 key here, right below the math key, that takes us to the matrices. And you can see there's a whole list, A through, you can have, well, there's more than 9 there because I got an arrow going down. All right. So when you put a matrix in your calculator, all right, you have to go to Edit. All right. So we're going to go over to Edit. All right. And then you can select which one you're going to do. So we've got an A, B, and C. So we're going to do A, B, and C here. All right. So we select A. All right. And the first thing you have to do is put the dimensions in there for that matrix. All right. So matrix A, what are the dimensions of matrix A? Michael, what's matrix A? 3 by 2. All right. So we go 3, enter, 2, enter. All right. So it sets it up for us. Okay. Some of you probably already have some matrices in yours, right?
I'm pretty sure it's 2 by 3.
Is it 2 by 3? Two rows, 3 columns? Okay, 2 by 3. All right, so we got to fix that. That's all right. Okay, back here, 2 by 3. Or 3, there we go. All right, so we enter in the numbers. So will you read me the numbers going across off Scott's paper? Okay? Okay? All right? I got 33 there, don't I? Okay. Is that right? Everybody good with that? Okay. So go back to there. Okay. Second x negative 1. Go over to edit again. All right. Go to matrix B now. All right. And put in matrix B. Okay. Matrix B is a 3 by 2. All right. So we enter those numbers, we enter them by rows, okay? All right.
Oh, I don't have to.
Who's got them written down? You guys have them written down? Zoe, okay, thanks, Zoe. Zero. Okay. Here's our matrix B. Great. All right, so same thing. Second, and then the x negative 1, you get to the matrices. Go back over to edit, and let's do letter C then, matrix C. All right. Matrix C is a 2 by 2. All right. And we've got 11, negative 1, 12, and 10. 11, negative 1, 12, and 10. All right? So go to your home screen. So quit. Boom. All right? Make sure your home screen's clear. Nothing on it. All right? Now, we want to multiply B times C together. So we go to our calculator. We do matrices. Letter B is number 2. And then we want letter C. And you do not have to put a time sign between them. It understands that if they're next to each other, it is multiplication. All right? And then press enter. And there's your matrix. That was a lot easier, wasn't it? Okay. All right, and then the same thing for C times A. Matrix C times matrix A. All right, and we get those numbers. All right. She was right. She did good. Okay. Ooh, man, that's much more fun. Much easier. Okay. All right, so here we have 2 stores held sales on their videos and DVDs with prices as shown. It says use the sales data to determine how much money each store brought in for the sale on Saturday. Okay, for a sale on Saturday. So we are going to multiply these together, all right? Because these are the prices for things. These are how many they sold. Notice, okay, that the column for sale prices, the headings, matches the rows for the sales. Okay, so they have to be the same for this to be able to happen, all right? So videos, DVDs are the columns here. Videos, DVDs are the rows here. All right. So we're going to make this matrix A, and this is going to be matrix B. Okay. So put them. We're going to use our calculator for this. All right. And then we're going to talk about what they mean. All right. So matrix A will be sales price, a 2 by 2. Matrix B, the total sales, will be a 2 by 3. All right. So we get these numbers when we multiply them. The question is really, what do they mean? And so that's what I want to talk about, is what these numbers represent. And so what these numbers are then is that this is how much money they made on those days. So here is Video World is now row 1. Star Movies is row 2. And Friday, Saturday, and Sunday are our columns. Okay? So Video World made $683.85 on Friday. Star Movies made $712.50 on Sunday. Okay? So when you have the application of these, right, you need to understand what they're talking about. So it says, use the sales data to determine how much money each store brought in from the sale on Saturday. So the sentence I would write here would be that Video World has $851.05 on Saturday, and Star Movies has $832.50 on Saturday. So here's my Saturday numbers. These two here represent how much money they made on Saturday, right? So remember, if you're working with a word problem, the columns here and the rows here have to be the same for it to work. Okay? All right, last thing. All right? And we're not going to spend time on this because we're using our calculator anyways. Right? Square matrix, right? Multiplicative identity matrices. All right, if it's a square matrix, it just means that the rows and columns are the same. And the thing is that if they are square matrices, you can raise them to a power. Okay? If they're not square matrices, you cannot. All right? So to be able to raise a matrix to a power, it has to be a square matrix, and these you just plug in your calculator. All right? Easiest thing to do. All right? Now, a 2 by 2 is really easy because you can multiply them pretty simply. The 3 by 3, or something to the third power, or when you're multiplying 3 by 3 together, it gets kind of tough. But all right, so these you can just use your calculator if possible. When it says if possible, it's because if the dimensions are not the same, then you cannot raise them to a power. Okay. All right. Questions?